and welcome to Mrs. Russell's math session. It's about 5 o'clock Eastern Standard Time, so I'm going to go ahead and get started. Today I'm going to be talking about arithmetic sequences for the lesson, and then the review part will be about scientific notation. So to get started, we're going to review what is an arithmetic sequence. So in order to figure out if something is an arithmetic sequence, you're going to look at the difference between terms. So for example, in here we have the sequence 4, 8, 12, 16. So we want to know, is this an arithmetic sequence? So in order to do that, we're going to look at the difference between the terms. So for example, between 4 and 8, the difference there is 4. 8 to 12 is 4. 12 to 16 is 4. So since the difference is constant, it's always the same, yes, this is an arithmetic sequence. And then oftentimes they'll ask, what's the next term? So we're adding 4 each time, so you'd add 4 to 16 to get 20. All right, another example. 2, -1, -4, -7. So to get from 2 to -1, you would subtract 3. -1 to -4, you'd subtract 3. -4 to -7, you'd subtract 3. So the difference is always -3. So yes, this is an arithmetic sequence. To get the next term, we'd subtract 3. So -7 minus 3 is -10. And then the last one here, 3, 5, 8, 12, 17. So the difference to get from 3 to 5 is 2. 5 to 8 is 3. 8 to 12 is 4. 12 to 17 is 5. So you notice there's a pattern here, but is the difference constant? Is it always the same? It is not. So therefore, this is not an arithmetic sequence. So even though there's a pattern, it has to be the same number added or subtracted to be arithmetic. All right, so go ahead and try these 3 on your own. Pause the video, try them, and then pick back up and you can see how you did. All right, welcome back. So to see if it's an arithmetic sequence, we're going to check the difference. So to get from 3 to 6, you add 3. 6 to 12, you add 6. 12 to 24, you'd add 12. So is the difference constant? Nope, it's changing every time. So this is not an arithmetic sequence. 5 to 1, you'd subtract 4. 1 to -3, you'd subtract 4. -3 to -7, you subtract 4. So notice the difference. We're always subtracting 4. So yes, this is an arithmetic sequence. The next term, to get the next term, we would subtract 4. So -7 minus 4 is -11. All right, and then the last one, 10 to 15, we'd add 5. 15 to 20, we'd add 5. 20 to 25, we'd add 5. So the difference is always constant. So yes, this is arithmetic. And the next term, to get it, we'd add 5, so it'd be 30. All right, now let's just do an example. Let's say you had 10, 15, and then 19, and you wanted to know if this was arithmetic. Actually, let's do 10, 15, 20, and then 24. So you add 5, but then you only add 4. So this would not be, because even though you added 5, this one changed. So this would not be. All right, there is a formula for an arithmetic sequence, and this is called the explicit formula because you can get any term from the formula. So this says a sub n equals a sub 1. So this means the first term plus n minus 1. N stays as n because that basically means the term number, times D, and D is the difference. So if you're adding 5 every time, D would be 5. If you're subtracting 3 every time, the difference would be negative 3. So we're going to use this formula to write explicit formulas for sequences. Okay, so this says find the explicit formula for, and here's our sequence. So the terms we need to know are a sub 1, so that means the first term. So the first term is 3. And then we need to know the difference. So if we look at this, we're going from 3 to 6, so we're adding 3, 6 to 9, we're adding 3, 9 to 12, 3, 12 to 15, adding 3. So our difference every time is 3. So it just happens to be our first term is 3 and our difference is 3. So using that formula, let me just write it here. A sub n equals a sub 1 plus n minus 1 times d. So we're going to keep a sub n because that's just like kind of like y equals. A sub n equals a sub 1. Well, that's our first term, which was 3, plus n minus 1. So that's going to stay as n minus 1. And then we're going to put in the difference, which was 3. So that would be our formula, and you can always simplify it. So you'd have, you can distribute this 3. So you'd have 3 plus 3n minus 3. But if you simplify that, the 3's cancel, so the formula would just be 3n. So what that means, let's say we wanted the 4th term, we'd want a sub 4. That means the 4th term. And it would be 3 times n. Well, n is what term we want. So we want the 4th term. So we do 3 times 4, which is 12. And notice, if we go back to our sequence, first term was 3, second term was 6, third term 9, fourth term was 12. So our formula is correct. All right, I'm pulling up another example here. So here's our sequence, 7, 11, 15, 19. So it's arithmetic because each time we're adding 4. So the 2 things you need to know are a sub 1, the first term, and the difference. So our first term is 7, right here, and the difference every time is 4. So go ahead and pause the video and try to write the explicit formula, and then after that we'll talk about how to find the 50th term. All right, welcome back. So our formula, a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals the first term, well the first term is 7, plus n minus 1, and our difference is 4. So you can leave it like that, or you can simplify it. So if we simplified, we'd have distribute that 4, we'd have 7 plus 4n minus 4. 7 minus 4 is 3. So our simplified would be a sub n equals 3 plus 4n. So to check it, let's say we wanted the 3rd term. So if we want the 3rd term, we're going to take this formula and put in 3 for n. So we'd have 3 plus 4 times 3. So again, we're looking at this formula. If I want the 3rd term, I'm going to do 3 plus 4 times, instead of n here, I'm going to put in 30. 4 times 3 is 12, plus 3 is 15. So notice the 3rd term is 15, and that's what we got. So now it asks for the 50th term. Well, we could write out all 50 terms, but that would take quite a bit of time. So by finding the explicit formula, that will save you time. So basically, we're going to take this formula that we found, and if we want the 50th term, so we want a sub 50, we're going to do 3 plus 4 times, what are we going to put in for n? We want the 50th term, so we're going to put in 50. So 4 times 50 is 200, plus 3 is 203. So that means if we kept writing these numbers out by adding 4, when we got to the 50th term, it would be 203. All right, and you can do the same thing if it goes down by a constant number. So let's say we had 3, -2, -7, -12. So notice this is going down 5, down 5, down 5. So our first term is 3, and our difference, since it's going down 5, would be -5. So if we write our formula, a sub n equals the first term, which is 3, plus n minus 1 times the difference. Well, since we're going down by 5, we're going to put -5. And that's times, you don't want to make it, it's not -5, it's times -5. So again, if we simplified this, you'd have 3 plus, we distribute, so it'd be 3, -5n. -1 times -5 is +5. Combining like terms, we have 8 plus -5n. So that would be our formula. And again, if you want to check, let's say we want the 4th term, we plug in 4 for n here. So -5 times 4 is -20, plus 8 is -12, so it works. So if it's going down, your numbers, your difference is going to be negative. All right, so normally now we'd have time for questions, but since no one's here, I'm going to move on to the review session, which is going to be about scientific notation. So scientific notation, if you recall, a number is in scientific notation if it's a number, So a number would go in this box. That number has to be greater than 1, but less than 10. So any number between 1 and 10 times 10, and you raise it to a power. This power can be either positive or negative, depending on if you have a large number or a small number. All right, so if we want to put a number in scientific notation, 562, you have to put the decimal where the number is going to be between 1 and 10. So notice if I put it here, that would be 562, so that wouldn't work. If I put it here, that would be 56.2, so that wouldn't work. If I put it here, it'd be 5.62. That would work because 5.62 is between 1 and 10. So there's our first number. Times 10, and then you're going to take where your decimal point is, and you're going to see how many spots you have to move it to get it to the end. So we'd have to go 1, 2. So our exponent would be 2. So scientific notation for that would be 5.62 times 10 to the second. 2,308, if we put the decimal at the end, that's 2,308, not between 1 and 10. If we put it here, 230.8, not between 1 and 10. If we put it here, 23.08, not between 1 and 10. But if we put it here, 2.308, that number is between 1 and 10. So it's 2.308, and then to get that decimal to the end, we have to go 1, 2, 3, so it'd be to the 3rd power. All right, 18,456. So think to yourself, where would the decimal go? So if we put it here, that would be 18.456, which is not between 1 and 10. If I put it here, 1.8456, that is between 1 and 10. So that would be my front number times 10, and then we have to move it 1, 2, 3, 4 spots to get to the end, so it'd be to the 4th power. And then lastly, 52. If we put it here, we have 52. If we put it here, we have 5.2, which is between 1 and 10. So 5.2 times 10, and we'd only have to move it 1 spot to get to the end. So it'd be 10 to the 1st, or you can just leave that as 10. All right, now what if you have little numbers? So these numbers are less than 1. So again, the same idea. If I had the decimals here, that's not between 1 and 10. If I put it here, I'd have 0.56. That's not between 1 and 10. So if I put it here, 5.6 is between 1 and 10. So it's 5.6 times 10. So now here's my decimal. I want to get it back to where it was. So I have to move to the left 2. So if you're going to the left, it's to a negative exponent. So negative exponents are tiny numbers. 0.0145. If I put the decimal between the 1 and the 4, I'd have 1.45, which is between 1 and 10. And then to get this back to where it originally was, I have to move left 2, so it'd be to the negative second. 0.000341. If I want the number between 1 and 10, I'm going to put the decimal between the 3 and the 4. So I have 3.41, because 3.41 is between 1 and 10. And then here it is. To get to the original, I go 1, 2, 3, 4. And since I'm going to the left, it's negative 4. So go ahead, pause it, try the last one, and then come back and check in. So if you tried this, you'd have the 4.82 would be between 1 and 10. And then you have to go back 1, 2, so it'd be times 10 to the negative 2. All right, so pause the video for a moment, take a second to try these two. So notice one of the numbers is a large number, one's a small number. So one of them's gonna have a positive exponent, the other one's gonna have a negative. So pause it, take a minute to try it, and then come back and see how you did. All right, so now that you completed these, the first one, in order to have your number between 1 and 10, we're gonna put the decimal between the 3 and the 4. So we'd have 476 times, so here's our decimal. To get it, really it should be at the end, so to get it there we got to move 3 to the right. If you're going to the right, it's positive, so times 10 to the 3rd. On the second one, your decimal would go between the 5 and the 2, so you'd have 5.28 times 10. So here's the decimal, but we want it back here, so we're moving left 2. We're going to the left, it's going to be to a negative exponent. All right, so now what I'm going to do, my iPad is taking a minute, is now I'm going to give you a number in scientific notation. We want to put it in standard form. So if you notice, this is a positive exponent. So this means it's going to be a big number. So a positive exponent, we're going to take that decimal and move it to the right 4. And then wherever there's blanks, we're going to put in with zeros. So this would equal 53800. So 53,800. Here we have the 3, so that means we're going to take the decimal, move it over 3. There's no zeros to fill in, so it's 4,657. All right, now on this one, notice now we have a negative exponent. So we're going to take where the decimal is and move it back 3. And I'm going to move this over a little. So here's our decimal. We're going to go back 1, 2, 3. And so these humps where there's nothing, we're going to fill it in with zeros. So it'd be 0.00362. So remember, if it's a positive exponent, you're going to get a bigger number. If it's a negative exponent, it's a tiny number. 4.998 times 10 to the negative fifth. So we're going to go back from where it is, 5. 1, 2, 3, 4, 5. Fill in your humps with zeros. So we have 0.00004998, which is a very small number. This one, it's positive, so that means we're going to go left or right. So we're going to go to the right. So we're going to go 1, 2 to the right. There's going to be our decimal. So we didn't quite make it to the end. So that would be 204.6. All right, so that was a quick review of scientific notation. Hopefully that jogged some part of your brain that you'll remember learning that before, because it's always useful to know. If you made it through the video, thank you for taking the time to watch it. And if you have any questions, be sure to reach out to me via the chat system or email. Thanks so much for watching and have a great day.